Okay, today we're going to be talking about volume. And it says the volume of a three-dimensional figure is the number of non-overlapping unit cubes of a given size that will exactly fill the interior. The volume of a figure is really the capacity. Or you can think about it as the capacity, how much it would hold if you were filling it up. And today we're going to talk about a little bit about Cavalieri's principle. Cavalieri's principle says that if two three-dimensional figures have the same height and have the same cross-sectional area at every level, they have the same volume. Now that sounds pretty confusing, the wording of it, but if you take a look, I think the pictures do a pretty good job of explaining that when I am given my two prisms here, they have the same height and they have the same cross-sectional area, kind of meaning even if we looked at the bases would have the same area. But even though one of them is at a slant, which you may hear that as oblique, that both of these would have the same volume. And I really like the example when you're given a stack of coins. This is showing a stack of quarters. And let's just say there's 15 quarters here. Even though if we change our stack a little bit by pushing it to one side, the volume still stays the same. I still have 15 quarters. So that is showing that even though they look a little bit different, they have the same height, the same cross-sectional area, but their volume would be the same. And again, they call this sometimes an oblique prism. You see that word right here. Okay, so how do we calculate the volume? Well, the volume, again, we're thinking about filling up our container with non-overlapping unit cubes. Well, you'll see the formula for volume given as capital B times H. But here, the capital B is something important. Capital B means the area of the base. Capital B means area of the base. And our base, we know, for prisms can be different shapes. So in this case, it's a triangular prism, but in this case, I have a rectangular prism. And so the way that you calculate volume depends on the shape of your base. Now, you probably learned in middle school that your volume for a box is simply length times width times height. And that's true. This, length times width, is actually the capital B. That's your area of the base. And a cube, well, you may have learned that as side times side times side, or S cubed. And that is true as well. I'm still finding the area of my base times the height. It's just that all my dimensions are the same. So let's take a look at example A and do some calculating. So I'm looking to find the first one, the volume of my rectangular prism. I'm simply going to take the area of my base, 10 times 5, and multiply it by the height of 6. And so multiplying those two together, we get 300. Now our volume is going to be labeled as inches cubed. Okay, inches cubed. We're actually seeing if we had our little cubes, how many of these little cubes it would take to fill the entire prism. And so that's a cubic inch. It would take 300 of them. Taking a look at number 2, this one can sometimes be a little bit confusing because kids will want to take the 12 and 10 as the base. But this is actually tipped on its side. This is actually a triangular prism. And so this right here is actually the base, right? The two triangles are the base. It's tipped on its side. So if I'm going to take area of the base times height, in this case, my triangle is 1/2 base times height. Well, my triangle here is a right triangle, so I'm actually going to take 12 and 16 as the base and the height. of the prism be? Yeah, the height of the prism, because it's tipped over, is actually this dimension right here, times 10. Now, once I have that all kind of figured, it's not too bad. We're just going to multiply straight across, right? Multiply all our numbers together, and we would find out that we would get 960. Okay, figure 3. That looks a little bit tricky. What do we have in figure 3? Well, looks like we have a hexagonal prism. Our bases are hexagons. Now again, we're still using capital B times H, but this time we need to find the area of our hexagon. Now, when we think about finding the area of our hexagon, remember we're thinking about splitting it into triangles. And it looks like we're going to need to think about what our apothem would be. Well, in my hexagon, we know that our central angle would be 60, and once we split that, we end up with a 30, 60, 90 triangle here. I could go ahead and use the SOHCAHTOA, or I could use the fact that if this is a 30, 60, 90 triangle, and this part of my base is 4.5, my apothem is going to be 4.5 root 3. Again, I could have used my SOHCAHTOA. I could have done the opposite and adjacent, so I could have used tangent of 30 degrees equal to 4.5 over A for my apothem, and I should get the same number here. So finding my volume, first I'm going to do that for the hexagon, right? We are going to take 1/2 times 9 times 4.5 root 3 times 6. All of that is for my hexagon. Base and height of my triangle, I have 6 triangles. Then I need to go ahead and multiply that by 12. Why 12? Well, 12 is the height of my prism. So we just have to be careful that we have all our numbers in the right spot, as well as if you're entering this in your calculator, you want to make sure that you close that parenthesis off. When you enter this in and you find your volume, we're going to round it to the nearest tenth, and you should find that you get about 2,525.3 cubic feet. So double check those, enter that in, and see if you can come up with that number. Okay, on page 2, we're going to talk about the volume of a cylinder. Well, guess what? The volume of a cylinder is actually the same, capital B times H. But we know the area of, capital B means the area of the base. But in this case, what is the shape of our base? Well, the base is a circle. And so sometimes people may refer to this as pi r squared H. This is the area of my base. Now, same goes, my cylinder, whether it is upright or oblique, these two would have the same volume provided that the base circles are the same size and that they have the same height. I use the same formula, so in example B, even though my cylinder is oblique at an angle, I'm still going to use the area of the base times the height. Now here, I'm going to do a little bit of thinking. My radius is actually going to be 9 inches. It asks us to give our answer in terms of pi and round it to the nearest tenth. So what would that look like in terms of pi? Well, my base is pi r squared times the height of my prism. And so what I'm going to do is I'm going to multiply out the number part of this. I'm going to square 9, and then I'm going to multiply it by the 14. So I'm going to take 81 times 14. So in terms of pi, I'm actually going to leave that as 1,134 pi cubic inches. And then, of course, as my decimal, I'm just going to go ahead and multiply those two numbers together. And you should find that we get about 3,562.6 cubic inches. All right? Well, what if we think about our volume of our prism and our volume of our cylinder were both capital B times H. Well, remember, a prism and a cylinder both have two bases, a top and a bottom. What happens if our figure is a pyramid? In other words, it comes up to a point. Well, if you take a look down below, we know the volume of a pyramid, because it comes up to the point, would really be less than if this figure was a prism. Here, showing me my prism, showing me a pyramid, this is going to have less volume than my prism, correct? And while it's a little hard to see in this picture, what they are trying to show you is that if I took this pyramid, placed it here, this one here, I can actually fit 3 of those pyramids inside this prism. So the volume of a pyramid is related to the volume of a prism with the same base and height. The relationship can be verified by dividing the cube into 3 congruent square pyramids. What does that mean? Well, that actually means when you find your volume of a pyramid, it is 1/3 capital B times H. 1/3 the area of the base times the height. Again, our base shapes may vary, so it depends. Our formulas aren't always going to be the same. This still means the area of the base. We just have to remember to multiply it by 1/3 or divide it by 3. If we had a cone, same thing, it's going to hold 1/3 of the amount, and so it's still 1/3 capital BH. Or we know that our base is a circle, and so we can refer to that as 1/3 pi r squared h. So let's flip it over and take a look at a couple examples. First of all, on the top, I want to take a look at this pyramid. If you can see the numbers given, and I asked you about the height of that pyramid. Would the height of the pyramid be 30 or would the height of the pyramid be 34? Yeah, this is actually the pyramid height is 30 inches, dropping straight down here and meeting at 90. This we'll talk more about later, but this is actually going to be referred to as the slant height. It's actually kind of the height of this triangular face, but it is not used when we're calculating volume. Okay, so this we would not use the slant height. We would use the height of our pyramid as 30. Example C, we're going to do a little bit of calculating. Well, my volume here, 1/3 capital BH. I have to ask myself about the shape of my base. In this case, the shape of my base is a rectangle. And so I know rectangle is length times width, or base times height. We're going to use 13 times 6. The height of my pyramid is 14. And we are simply multiplying from left to right. When you multiply those together, you should find that your volume is 364 cubic centimeters. Now, the second one is a cone, and I actually see on my cone here that 34 is my slant height. So I actually need to calculate my height. But that's not going to be too tough because I see here I have my right triangle. So I can go ahead and use the Pythagorean theorem. We're going to say that 16 squared plus h squared would equal 34 squared. And calculate that out. We'd actually find that the height is 30 centimeters. Okay, so if I go to find my volume, now here I need to remember that my base is a circle, pi r squared times the height. If I wanted to give this answer in terms of pi, I could do that. I would take my 16 squared, or 256, times 30, and I would divide by 3. Or really, if those are going to be 10, I could just multiply by 10. So in the end, we would find that it would be 2,560 pi cubic centimeters. That would be an exact answer. Or I could go ahead and multiply that out to find my estimate of 8,042.5. Okay, let's take a look at the last one, example D. Example D shows us a composite figure, and so we need to do a little bit of strategy, finding the volume. Sometimes it's a little bit hard to tell, but what they're actually showing here is a rectangular prism, and this part in the center has been removed or cut out. So I'm looking for the volume of the composite figure, what would be left kind of on the inside, if you will. So what do you think our strategy would be? Well, strategy a lot of times kids will tell me is we need to take the prism and we need to subtract the pyramid. And that would work. The volume of my prism, well, we know the rectangular area of the base times the height, or length times width times height, would be 25 times 12 times 15, and we need to subtract out my pyramid. Well, my pyramid would actually be 1/3 the area of the base. Well, my base here, 25 and 12, and my height of my pyramid would be 15. Now, if you take a look at this, what do we know about this composite figure? Well, 1/3 of it was actually removed. 1/3 of it was removed. So really I could maybe just take my volume of the prism and multiply it by 2/3, because 2/3 of it would be left. Either way, in the end, when you calculate that out, you get 3,000 cubic feet. Okay, if you have further questions on this, please stop in and see me.